So you're ready to buy a new marine monitor, or maybe several marine monitors for your boat or yacht. How do you go about evaluating different monitors to make sure that you end up with the right monitor that's best going to meet your needs? I'm Keith with Green Marine Monitors, and that's what this video is all about. This is the first video in a two-part video series on how to evaluate marine monitors. In this first video, we want to walk you through step by step how to read a specification sheet from a manufacturer as listed on their brochure or their website. Different manufacturers list things differently, and we want to help you with information so that you can make sure you're getting an exact apples-to-apples comparison of each product that you're trying to evaluate. So the first thing that we want to take a look at on the specifications page is the actual outside dimensions of the monitor. Obviously, it makes sense that if the monitor isn't going to fit correctly into your console, that there's no sense in looking at the product any longer. Now this seems very obvious, but I just want to mention this because typically on a spec sheet, there's going to be two different outside dimensions. Usually the display information is listed at the top, and those dimensions are simply talking about the actual picture display itself. So you just want to double check to make sure that when you're looking at the outside dimensions that it's the mechanical dimensions of the actual monitor case itself, so that you make sure that you have enough clearance. So the next thing that we want to look at are the signal inputs to make sure we have enough inputs on the monitor to handle all the signals that are going to be fed to it. So when you're laying out your project, either an electronic installer, if they're doing it for you, they're going to put together a signal schematic. Now this is a very simple signal schematic, but they can get very complicated for large yachts like this one. Now if you're doing the project yourself, obviously you're going to have to put together a signal schematic, which is basically just laying out all of your different electronic components and then making sure that you've got enough signal inputs on the back of the monitor to handle all those signals, be it from a camera system, a radar system, your chart plotter, whatever's coming in to the back of the monitor. You need to make sure that you have enough signal and the right signal types to handle all the different signals from your components. So on the spec sheet, we can look on this particular monitor, and it has 2 VGA inputs, 2 DVI inputs, and 3 composite inputs, as well as an RS-232, which is probably there for a controller or for diagnostics. So that's quite a few and gives you a lot of different options. On this particular monitor, we have a video, 1 DVI, and 1 RCA, and 1 S-video. So again, 4 inputs to choose from. So whether you have 7, 4, as long as the monitor has enough inputs for all of your electronic devices, you should be good to go. The next thing is brightness. It's normally listed at the top of the specification sheet because it's one of the most important specs on the monitor. On this specification sheet, you can see brightness listed as 1000 CD/M2. That's 1000 candelas per meter squared, which is a measure of brightness. So in my opinion, the minimum brightness for a marine monitor to be considered sunlight readable is 1000 nits. Now there's other technology such as bonding that can take a monitor that's not quite as bright and still enhance it to the point where it would equal. So a 500 nit monitor with bonding might be equal to the viewability of a 1000 nit monitor without bonding. I know that gets a little bit complicated, but one of the things that I want you to take a look at here is something that maybe you haven't considered. When I'm looking at this particular brochure, it's showing a light intensity, which is again the brightness, standard 400 brightness, but then it says high bright 800. So I'm guessing that this product has two different options on it, one a standard bright model and one a high bright model. Now both of these include bonding, so both of them would still probably be considered sunlight readable, although the 400 nit version is right on the border. Now on this particular model spec sheet, we have two different listings for brightness, but it's not because they have two different models. They have sunlight brightness 1200 nits ambient backlight brightness 450. So what we're looking at when we see something like this, where there's two different readings, and also the key word here is ambient backlight. That means the actual backlight brightness of the product, is we're dealing with something called a transflective display, which is a very different technology than a pure high bright display. A transflective display uses a standard bright display but puts a mirror type of system in the backlight so that when the sunlight shines through the front glass, it hits off of the mirror and reflects back up through the display, which is what powers then the display to be sunlight readable. Now, it doesn't mean that transflective displays aren't a good technology and may not be a good fit for you in regards to a marine monitor. It's just a very different technology. So a transflective display requires the power of the sun for it to be sunlight readable. A pure high bright display is using the power of the LED backlights alone to power extra light up through the display and to make it sunlight readable. So if you're out on an open water boat on a bright day with the sun shining down on your monitor, transflective may be a great technology for you. But if your boat has a cover over the top, or you're out on a cloudy day where there's still a lot of reflections of light and high ambient light around you, but there isn't any bright sun to power onto a transflective background and shine back up through the display, that technology may not be the best for you. And a pure high bright technology where you've got the power of the backlights working for you all the time may be the best way to go. The other aspect of brightness we want to check is the nighttime viewability of the product. Obviously, it's just as important to be able to view the monitor in a nighttime setting as the brightness is to the importance of viewing it in a daytime setting. So on the specifications, we want to make sure that the unit dims 1 all the way to black if you want to totally black out the monitors for nighttime viewing. And also, if you want to see the screen in very dim light settings, we want to make sure that it dims down on its last setting to under 1 nit, or under 1 candelaria per meter squared. Next, we have contrast. Now, contrast is simply the difference between the brightest whites and the darkest blacks on the picture. So if we're designing a high bright display and all that we're doing is increasing the amount of light coming through the product, but the whites are still just as, even though they're brighter, there's no difference between them and the blacks. The blacks got brighter and the whites got brighter at the same ratio. We really haven't increased the viewability of the display itself. What we need is good contrast, which is actually what your eye sees. In this example, you can see that the circle inside of the square are both the same brightness of white. However, the one against the darker background, the black background, looks a little bit sharper and a little bit brighter. That's due to the fact that it's surrounded by a darker black. And that's what contrast is, and that's what your eye sees when you're looking at a display. In my opinion, for a marine monitor to be a good sunlight readable product, it needs to have a minimum contrast ratio of 500 to 1. So we see this product that we looked at before that has two different models. You'll see that the contrast ratio for their standard bright model is 700 to 1, and their contrast ratio for their high bright is 800 to 1. And that's good. That means that they didn't just push light through the product. The brighter product should have a little bit higher contrast ratio if the product was built correctly. This particular model we see is 1000 nit brightness with 1000 to 1 contrast ratio, which that particular model should provide excellent sunlight readability, not only in brightness, but having excellent contrast ratio for your eye to see. Next, we have viewing angle. Now, different manufacturers, not just marine manufacturers, but panel manufacturers, list viewing angle a whole host of very different ways. So the bad news is I can't even really give you a way to do an apples to apples comparison of viewing angles. The best suggestion I can recommend, and we'll talk about this in our second video in this series, which is about actually going and looking at a marine monitor in a hands-on environment, once you've narrowed it down to your final choices, is to go look at viewing angle with your naked eye to make absolutely sure it's going to work for you. But something you can do beforehand is this. We're going to pretend that this is the console of your boat, and this is just a simple application that I believe was free, an app on my iPhone. It's actually called RIDGID Digital Level. So you can get any type of digital level app on your phone. You can place it against your console, and what you're going to get is a digital reading of the angle of your console. Mark that down, and then when you go into the dealership, put the monitor that you're looking at the same angle, step back to about the same place that you're going to be viewing from your boat, looking at the monitor to make sure that your viewing angle is going to work well for you and be acceptable to you on that particular product. Next, we have waterproof protection. Now this is obviously more important if the monitor is going to be used on the fly bridge or in an outside on the boat application versus in a nice plush pilot house, unless you're prone to dumping your morning coffee on your console. But these ratings are normally done as an IP or a NEMA rating. IP stands for ingress protection, and it's usually followed by two numbers. As we can see on this brochure, this panel has a rating of IP 65. Now the first number has to do with the solids protection versus dust, ingress, other particles. So a 6 is a very good rating there. Let me just say the higher the rating, the better. 5, the second number on the brochure, has to do with liquid ingress. And a 5 is a rating of light spray on the product. So to be able to spray the monitors off, if they're out on a fly bridge while you're hosing them down, you probably want a rating of at least 5 for that second number. 6 is even a water jet being able to be sprayed on the front of the product and still being able to sustain that in a sealed manner. So the other thing to look for is the IP rating simply the front of the monitor or the entire monitor? Now typically if your monitor is going to be panel mounted and has a gasket, as long as it's IP rated from the front, you're okay. On this particular product we see it says fascia waterproof to IP65. What that word means that it's from the front side of the monitor, and that's typical. However, if you're going to be using the monitor on a sailboat or on a pedestal mount outside where the back side of the monitor is also exposed, then you need to make sure that it's also waterproof from the back side, that it doesn't have any holes for fans, and that the connectors, whether signal connectors or power connectors, are also waterproof so that it's a totally rated system front and back. Also, you might see a NEMA rating instead of IP. They can be interchangeable, but basically you're looking for a NEMA rating of at least 4 to have a similar rating to an IP66 or IP65 monitor from the standpoint of waterproofing. Next we have power, and there's 3 things here that I want to look at in regards to the power of the monitor. The first is I'm going to be looking on the spec sheet for a DC pure marine grade power supply. You can see on this brochure that it's listing a 9 to 36 volt DC marine grade power supply, and it also happens to be fully isolated. That means the supply is isolated from the case itself, which is even better. What I don't want to see is a 12 volt AC system, which I do not consider to be a marine grade product. So in other words, I don't consider this to be marine grade. This type of power supply is for a laptop, not for a marine monitor. If you've ever had a laptop, normally the first thing that wears out on it is the power supply long before the laptop itself. These type of things just aren't made to hold up over the long haul and over the rigors of the marine environment. The next thing I want to take a look at is the actual connector itself, and it's one of the reasons I don't like these. Typically they have a barrel connector on them that's going to plug in. There's nothing to hold that connector in place with the vibrations and the shock of a boat that's out at sea. What we're looking for is a marine grade type of connector that either screws on or has terminal connectors where you actually have screws to tighten the wires against. Something that's permanent and something that's not going to come loose. The next thing in regards to power is the range of the power supply. On this particular product, we see that the power source is, it looks like they have options, either an 11 to 16 volt or a 19 to 36. Now the 19 to 36 isn't too bad, but we really recommend something that's more in the 9 to 36 range. That gives you a wide enough range that on startup of the boat that it can handle a very high spike, and plus a very low battery situation as well, down below a 12 volt system all the way to 9. That's where you're going to get the most reliability out of the product. And finally, in regards to power, we want to look at the actual power draw of the monitor itself. Here we have a product that's showing us that the brightness is 800 nits, but the power requirement to drive that particular product is 60 watts. On the other hand, here we have a product that's 1000 nits, and the power draw on it is only 40 to 45 watts. So that would tell me that this particular model, the second one, is a much more efficient product at using the LED backlights. It's a brighter product, and yet the power draw is much less, which shows me that it's a very sophisticated product as far as the technology that it's using from a backlight system. So hopefully we've been able to provide you with some good tips on how to properly read specification sheets from manufacturers on marine monitors so that you end up with the very best product for your boat. I'm Keith with Green Marine Monitors, and thanks for watching.